Geometry, Unit 9, Section 6, Solving Problems Using Tangent. The previous lecture was solving problems using sine and cosine, so we're going to see a lot of similarity between that. That's a little pun, too, because a lot of trigonometry comes from similar triangles. Feel free to laugh. So the thing about solving problems with sine and cosine, what we kept seeing was we kept setting up equations that were set up as the function followed by the angle equaling the ratio. And we had to determine if it was sine or cosine from a given angle's perspective, and the ratio that was created by that, typically, opposite over hypotenuse or adjacent over hypotenuse for sine and cosine. And one of those two things was an unknown variable x, and we would cross multiply. And we're going to see that the same thing today, except we're going to be working primarily with the tangent function. Why are we doing tangent separately from the other two? Well, tangent is separate from the other two. Sine and cosine are both a leg, a ratio of one of the two legs divided by the hypotenuse length, where tangent's a comparison of the two legs. Could also be thought of as slope, really, because that's what opposite over adjacent is, rise over run, things like that. So tangent is kind of special in that it's really comes, from a different perspective than sine and cosine do, where it's just working with the two legs. And so we like to do it a little bit differently. And we see a lot of word problems that come from this, a lot of modeling questions that are useful for the tangent function. So we know going into these questions that it's going to be the tangent function. But on a test or a Regents, of course, you wouldn't know that. You'd have to figure out sine, cosine, or tangent based off of what sides you're working with here. Um, so just always keep that in mind, that you usually have to determine the function. But for all of this today, it's going to be tangent. So let's look at these examples. Given right triangle GHI with right angle at H, GH is 12.2 and the measure of angle G is 28 degrees. Find the measure of the remaining sides and angle to the nearest tenth. So we got to find both these sides. But first let's find IH. Let me put an X there. And so how can we find this side? Well, this is the opposite side from angle 28's perspective, and this is our adjacent side from that angle's perspective. So that's how we know it's going to be the tangent function, tangent 28, because that's how function angle. And the ratio opposite over adjacent would be x over 12.2. And so now we can cross multiply to get an answer for x, and we're going to round to the nearest tenth here. And so using my calculator, it's going to be 12.2. Make sure I'm on degree mode. I am. 12.2 times tangent 28. And remember, sometimes it's 12.2 divided by tangent 28. That would be the case if x was on the bottom of my fraction here. So we get 6.5 when rounded to the nearest tenth, 6.5. And they did also want us to find this side over here. Now, I could find this one of two ways. Now that I have 2 out of 3, now that I know this is 6.5, I could do Pythagorean theorem here. But with these decimals, that's going to be kind of a pain. Let's stick with the theme of using trig. Now, it's not going to be tangent anymore because I'm working with the hypotenuse now. So I could do sine if I want to do 6.5 over y, or I could do cosine if I want to do 12.2 over y. Anytime a problem asks us to find two things, it's best to still work with the one they gave you, not with the one you found, because what if I found this wrong, and now I'm going to use a wrong answer to get another wrong answer? So you're better off sticking with, if possible, what you have. Sometimes you have to use the answer they give you, but in this case we don't. We could get away with cosine 28 degrees is going to be 12.2 over y. And this is going to be a scenario where I'm going to have to do 12.2 divided by cos 28. Because if I cross multiply here, I get y times cos 28. So I'll end up having to do y equals 12.2 divided by cosine 28. And to the nearest tenth. So 12.2 divided by cos 28 is the nearest tenth, 13.8. And that sounds right based on what I see my other sides are and how the problem looks. So 13.8. And then I also wanted the other angle. That's just three angles. That's 180. So that's going to be 50, 60, 70. No, it's going to be 60, 70, 62, 60, 70, 80, 90. Yep, 80, 62 degrees. Okay. So here are these fun modeling questions we see a lot. Scott, whose eye level is 1.5 meters above the ground. So his eye is 1.5 above the ground. And I guess I'll just use my pen here, that this distance here is 1.5. And they tell us that Scott stands 30 meters from a tree. So this distance is 30 here to here. The angle of elevation of a bird. So angle of elevation, and this next question is going to talk about angle of depression. Angle of elevation is basically, when Scott looks straight out, he would look, horizontal to the ground here. But when he looks up, his angle of elevation from a horizontal line, that's what we mean, angle of elevation here, is 36 degrees. And they want to know how high above the tree this bird is. Well, there's two things. We can first just find this length here, because he's kind of creating a triangle here with him looking straight out, and then the angle of elevation there. And we know this length down here is 30, and we could figure out this length over here. And then we know that this is going to correspond to his 1.5 here. So in the end, I could add these two values together to get the whole height of the tree. So for this little triangle in here, we have a 30 down here, an angle of elevation of 36 degrees, and we want to know how high this length is here. So we're finding the opposite. We have the adjacent, so that is the tangent function. Tangent 36 equals x over 30. Multiply 30 times tangent 36, and we get 21.7. I guess we'll do nearest tenth here again, so let's do 21.8. And 21.8 plus his 1.5 height with the eye level is 23.3. So 21.8 and 23.3 are our values. This is our 21.8, and 23.3 was our final answer. This is a case where a lot of students would get that 21.8 and think that that's their final answer. But the trig here, or triangle here, is only getting you this height here. We want to know the whole height, so that's why, why did they tell us his eye level is 1.5? That wasn't used in the trigonometry part of it, so you got to kind of sometimes ask, why are they giving me that specific information? So don't fall for that. All right, the lighthouse looking at a boat. We see this question all the time. So standing on a gallery of a lighthouse, and that's at the top of the lighthouse, a person spots a ship at an angle of depression. Again, so a person looking straight out would look like that. But looking down at a ship, I'm going to use my little line tool here to draw straight lines. This is what you would see looking straight out, of course. But looking down, angle of depression is looking down. This angle of depression of 20 degrees. The lighthouse is 28 meters tall. So that's that length. Excuse me. And sits on a cliff 45 meters tall. So how can we find the distance between the lighthouse and the ship? Well, you actually have two options here on what triangle you work with. We could work on this triangle here, which most students usually do prefer to. But the one thing you're going to have to realize is that this 20 degrees is not this 20 degrees. You have two options, that this 20 degrees is going to be alternate interior with this 20 degrees, or you could do the complement of 20 degrees, which would be 70 degrees here. So you could do that. Or you could work with this triangle up here, since we have 20 degrees, and the x here is basically like the x here, and then this length is the same as this length. So you're kind of creating a rectangle. Whichever one is best. As I said, most students tend to prefer with this triangle. They see this one a little bit better, so that's what we'll go with. And the 20 degrees angle of depression is alternate interior with this 20 degrees, so that's what we'll use. We'll go with this. And let's say 28 and 45, so I don't make any mental math mistakes. 28 plus 45 is 73 degrees, so that's what we see here. This is 73 meters long, and so that's going to be this length. We do not know the adjacent side of 20. We do know the opposite side of 20. So again, it's definitely the tangent function, and tangent 20 opposite over adjacent would be 73 over x. Now, if I use this angle of 70 in here, which was an option, opposite over adjacent would be x over 73. So the x would be on top, but the angle would be different. That's why it's still going to work both ways. It's going to be the reciprocal, like tangent of one angle is reciprocal of tangent the other of its complement. So this one I'll have to divide. X will equal 73 divided by tangent 20, but either way that's going to get me my correct answer. So 73 divided by tangent of the 20 degrees is 200.56. Did they say what's around to? What is the horizontal distance between? No, they didn't really say. So let's just go, whole number would be 201. So 201 meters is our final answer there. Okay, so very similar to solving problems with sine and cosine by setting up the equations. Angle of elevation is looking up from horizontal. Angle of depression is looking down from horizontal. Setting up, cross multiplying. Sometimes you do side times function angle. Sometimes you do side divided by function angle, depending if your variable is in the numerator or denominator. And that's working with tangent. See you.